Hello my dear students, welcome to chemistry classes. Today in this class we are going to deal with the interesting topic of the organic chemistry, that is none other than SN2 reaction. Okay, we are going to deal with substitution nucleophilic bimolecular reaction. It is in short, we can call it as SN2 reaction. Substitution nucleophilic bimolecular reaction. Here the S stands for substitution, N stands for nucleophilic, and bi means two. So bimolecular reaction. So it is a typical type of the substitution nucleophilic substitution reaction. So commonly we can see it in organic chemistry. SN2 is a kind of nucleophilic substitution reaction. In the mechanism of in this reaction, one bond is broken and one bond is formed simultaneously. Simultaneously means what? In only one step, a bond being broken and a bond being formed. Here, since two reacting species are involved in the slow step of the reaction. What do you mean by slow step? Here, dear students, please remember, in each and every reaction, the slowest step of the reaction determines the rate of the reaction. So it is called as rate determining step. So in SN2 reaction, the rate determining step, only two reacting species are there, means molecularity of the reaction is 2. So we can call it as bimolecular. So because of that reason only we can call it as bimolecular reaction. The reaction, so it is called as substitution nucleophilic bimolecular reaction. Because bimolecular, why we can call it as bimolecular reaction? Because at the rate determining step only two molecules are there. The molecularity of the that elementary step is only 2, so it is called as bimolecular reaction. This reaction is also called as, there are alternate names for this reaction, associative substitution. That is also same, associative substitution or interchange mechanism. We can call it as interchange mechanism, associative substitution or interchange mechanism. Okay, so this is the reaction. So dear students, please remember the there is one more reaction called as SN1 reaction. It is also same as that of this SN2 reaction with some possible variations. Okay, so you can remember SN1 reaction takes place by two steps and SN2 reaction takes place via one step. Here this reaction is a single step reaction. In the mechanism we can observe only one step. So in that step everything happens. Here the film starts and interval and the climax, each and everything is there in only one step here. So so let us consider, this is our reaction, this is our substrate molecule, and this is intermediate. On the substrate, nucleophile attack, this nucleophile attack on the central carbon atom, especially this carbon is sp3 hybridized carbon. Here in the reaction most commonly occurs at the aliphatic sp3 hybridized carbon. Aliphatic sp3 hybridized carbon contains electronegative, it must contain electronegative and stable leaving group. Here L indicates the stable and electronegative leaving group, and here the L most frequently we can take it as halide, because this reaction mainly observed in halides, alkyl halides. When alkyl halides react with some other nucleophiles, we are going to get such type of reaction. Here if a reaction to be followed SN2 mechanism, there is a condition, that is the groups which are attached to carbon other than leaving groups are, they are not be bulkier, they must be small groups, then only the reaction proceeds faster. Here for the sake of simplicity we can call XYZ as hydrogen, we will take it as carbon as methyl carbon. Okay, on this carbon nucleophile attack only from the back side, there is no possibility of attacking of the nucleophile from the front side. Why? It will get kick off. Why? Because nucleophile is electronegative, As it is electronegative, it contains more number of electrons. Electron density is high. If nucleophile is also highly electron dense, so two electron rich species come near to one another, what will happen? There will be a repulsion, because it also contains, nucleophile also contains electron, this living group also contains electrons, so there will be a repulsion here. Because of that reason, the nucleophile will come from the back door. Okay, so what happens? Nucleophile here, this carbon, and the nucleophile give the electron toward this carbon, and the bond between carbon and nucleophile being formed, and the strong bond between carbon and living group keep on breaking. Yeah, this is transition state. So this indicates transition state. In the transition state, carbon has got how many bonds? Check it out. 1, 2, 3, 4, 5. So if a carbon contains 5 bonds, it is highly unstable. So now the carbon becomes pentavalent. In this step, what happens? The bond between carbon and nucleophile being formed, and the bond between carbon and living group is broken here. So ultimately what we are going to get, there forms a bond between nucleophile and carbon, and the living group is left the molecule substrate. It is out of the substrate molecule, isn't it? The breaking of the Cl bond and formation of the new bond with the nucleophile CNU occurs simultaneously through a transition state. This is our transition state here, in which the carbon is pentacoordinate. Here the carbon becomes pentacoordinate. The valence of carbon is only 4, means it can form how many bonds? 4 bonds. But in this transition state, the carbon has formed 5 bonds, so it is unstable. As it is highly unstable, it break down to give the product. How it breaks down? It loses the bond between carbon and living groups. Here, dear students, remember, in organic chemistry, anything written in the square bracket is indicates it is highly unstable. And in this condition, the carbon is sp2 hybridized. It's approximately sp2 hybridized. Here the nucleophile has attacked from the 180-degree to the living group. It will not come along the living group. Why? Because there is a repulsion between the living group and nucleophile. So there is only possibility is it will attack from the back side. So nucleophile will attack from the back side. Here the SN2 mechanism of formation of methanol from the bromomethane. So this is the reaction. So here this is methyl bromide when react with our nucleophile, when react with any alkali. You can take NaOH or any alkali. So here for this reaction, for SN2 reaction, this alkali must be strong. Okay, we have to take nucleophile NaOH or KOH. Then what happens? This will attack from the back side. OH will attack from the back side because bromine is electronegative. This OH is also electronegative. There will be a repulsion between them. So it will attack from the back side. It will form this pentacoordinate transition state, in which the carbon to bromine bond being broken, the carbon to OH bond being formed. Ultimately, this bond completely breaks out, and the bond between carbon and OH is completely formed. So we'll get here, this picture clearly indicates here this is bromine, this is bromine, this is OH. Here the bond between bromine and carbon is broken, and the bond between OH and carbon is formed in only one step. Okay, next is, my question is this thing: why nucleophile attack from the back side? Why it will shear? The nucleophile generally attack from the back side, means 180-degree to the nucleophile or living group. Nucleophile attack from the 180-degree to the living group. Why it will attack from the 90-degree? Why it will attack from the 60-degree or other angles? It will not choose that option. Why? Because, so we can understand by seeing the structure. This is the structure of methyl bromide. Here the carbon to bromine bond is here, so this is bonding orbital, and this is anti-bonding orbital of carbon. Here when nucleophile attack from the back side. So now nucleophile easily donate its electron to the anti-bonding orbital of the carbon. So it becomes very much easy to receive the electron to the anti-bonding orbital. Now what happens, as carbon gets electron from the OH group, the repulsion starts here. As a result, what happens, the carbon starts breaking the bond between carbon to bromine. So here in the transition state, what happens, the carbon is pentacoordinate, the bond between OH to carbon is being formed, the bond between carbon to bromine is being broken. So ultimately what happens, the bond between OH group and carbon is formed, the bond between carbon and bromine is completely broken, isn't it? So this is because here the donation of the electron to the anti-bonding orbital is maximum only when the nucleophile attack from the 180 degree from the completely backside. So because of that reason the reaction takes place like this. Here when the nucleophile attack from the backside, it provides best overlap between the nucleophile's lone pair and anti-bonding orbital of the central carbon atom. Here the lone pair of electrons can given to the anti-bonding orbital. The leaving group is then pushed off from the opposite side. The product is formed with inversion of geometry. So this is important. Here the tetrahedral geometry of the compound is completely inverted. The geometry of the compound is inverted. Here let's study more about that inversion. Here that inversion is called as inversion of configuration is called as Walden inversion. Walden inversion. In SN2 reactions, due to the back attack of the nucleophile, living group is pushed off from the opposite side. So as nucleophile attack from the back side, living group is pushed from the opposite side. If the substrate is chiral, if the substrate is chiral means what? It is asymmetric. If the substrate is chiral, it leads to inversion of configuration, or the stereochemistry of the compound is inverted. If the substrate molecule A has R configuration, the product will get S configuration. If the substrate has S configuration, the product will be R of R configuration. So the inversion of configuration takes place. So the configuration of the compound, this type of here, if the substrate is chiral, it leads to inversion of the configuration of the compound. This type of inversion of configuration is known as Walden inversion. See here like this is normal umbrella. When it is open, if you put umbrella to the high wind, what happens, it is inverted. The umbrella is inverted, it is inverted. So this is like this. If you put umbrella at the high wind, it is open to the air in the opposite direction, what happens, it is inverted like this, isn't it? So this is called as Walden inversion. Here the first our groups are like this, now the groups are like this. Here like our umbrella, they are like this, and here they are inverted. This is called as Walden inversion. During this what happens, Walden inversion, as nucleophile attack from the backside, this nucleophile, there is an interaction between the nucleophile and these groups. As a result, these groups are pushed away from the nucleophile, so they will go to the opposite side. Okay, I hope all of you understood this, dear students. Thank you so much for watching.